Welcome to Unplugged, an IoT podcast where we dive deep into the fascinating world of industrial Internet of Things and automation. I'm your host, Phil Seboa.
It's a Friday here. Hi, Phil. Hi, everyone. My name's Ed Fuentes. We had a bit of a chat before this podcast started, but anyway, today we're with a very special guest, is Yanesh Naidoo. He's the owner of Jendamark Automation. They're a company in South Africa, and I'm sure Yanesh will tell us more about it, but they've been over 30 years in business, and Yanesh over 20 years with the business, and we're looking forward to hear his experiences. They are specializing in automotive assembly lines and advanced manufacturing technologies, exactly what we want to talk about. So thank you, Yanesh, for joining us today.
Thank you. I appreciate the invite.
Absolutely. So maybe we can, I guess, dive into a bit of the, the meat and potatoes of your business. Like, where did you come from? What are you trying to achieve? What's your customer base? Let's talk about, I guess, a bit more about your history there.
Yeah. So Jendamark is a machine builder. I think the German word is Maschinenbauer. So we would take a requirement from a customer that says, for example, here's the design of my engine. I want to make 100,000 engines a year. I want to work 3 shifts, and I want to have 10 operators a shift. Please come up with a solution for me. And kind of that's where our job starts. So we would have a team of people that would figure out the right layout, the right process, do the planning of the production line, cycle times, decide what should be automated, what isn't automated, have a consultation process with the customer, make a commercial proposal to them to say, okay, it's going to cost X. We would then, if we're successful, and fortunately we have been successful a couple of times, we would then go to the actual execution of the project. So we would design, manufacture, machine only 20% of the components. So we have a pretty big machine shop here. But only the tooling would be machined in-house. The rest of it would be outsourced through suppliers close to us. All of the components would arrive back, mechanical, electrical. We would assemble the individual machines, then put all the individual machines together on a conveyor system, to form the production line. And then we would program that production line to work, run it off on our shop floor. And obviously, customer would come around and they'll build 100 engines on our shop floor to prove it. And then we would pack it up and ship it to wherever it needs to go, and we'd send a team to install it. And that's in a nutshell what we do. We obviously started out as a pretty small business, like as you say, 30 years ago. And about 20 years, maybe 15 years ago, we took a decision. We're primarily delivering to South African automotive manufacturers, and we fortunately got a pretty strong automotive industry in South Africa. But we took a decision about 15, 16 years ago to try and get a 50-50 balance of, could we export some of our machines and 50% of them and do 50% of them in South Africa. And fortunately, where we are now is 95% of our machines are exported all around the world. And 10 years ago, we started Jendamark India. So Jendamark India does exactly the same thing, primarily for India, Southeast Asia. And from South Africa, we export to Australia, Europe, when you had a strong automotive industry. And obviously, all over Europe, US, South America, Mexico is one of our biggest locations where we have production lines. And our team has grown from, in 2010, I think we were like 60 or 70 people. We're now just on 800. So, and primarily that's what we do. So that's kind of our bread and butter. And we've had all the ups and downs of a typical business where we've had external factors that have influenced our business, negatively, positively. We've had internal factors where we kind of lose our way every now and then, and it's a typical sort of up and down scenario. I keep telling people, there's no one that's written a book to guide us on how to run a business. It's very interesting. A company from Africa that's exporting machines to Germany, there's certainly no book about that. So it's kind of, as we go along, we see what tomorrow holds and we try our best. And if we fail, we kind of pick ourselves up and try again. It's very much in the ethos of our culture and I guess our country.
Awesome. I mean, so I've seen some of the content that you're creating online, and you're kind of disrupting a little bit of the traditional sort of model of a board builder for sure, and diving deep into some of these other technology stacks. I guess we're seeing this, some of the topics that you're talking about is this IT and OT convergence style. So I was just wondering, maybe you can give us your insights into, what is IT, what is OT, in that manufacturing space, especially for automotive type companies. I guess, how are they adopting these types of strategies?
So I think what is different about us is that we're developing into somewhat of an IT tech company, but from mechanical engineering up, as opposed to the other way around, which does give us some advantages and some disadvantages for sure. Like, for example, cloud is something completely new for us. It's new, and we're now learning that, but we understand why collecting data on a 60 micron sensor is so important to predicting the outcome of a production line, for example. So there's pros and cons to our approach, and we're definitely a bottom-up approach to most tech companies, which is a top-down, or even system integrators are very much a top-down approach. But I think, to be honest with you, it's by no grand design that we've now entered into this IT OT space. It is out of necessity, actually. I wish I could say that it was a grand design and we are smart guys and we figured this all out and we've now got this thing going. But it's, as with most things in our company, we've stumbled across it, right? And it's very much because we're in the automotive space. And I think the automotive world has got one unique difference to many different manufacturing, and that's the concept of JIT, just in time, just in sequence. So I don't know if you guys are familiar with the term, but maybe for those that are not, it's what happens is if you order a BMW X5, for example, you go onto BMW's website and you go and say, okay, I want an X5. You choose the engine, you choose the seats. You may want a yellow cockpit with pink seats and purple gear knob and sunflower wheels, for example. And so you basically go and customize your car to your unique requirements. And so now BMW now need to build you a custom product, right? Yes, it has 4 wheels, it's got a steering column, it's got a cockpit, but each component within those sub-assemblies is unique to your specific requirement. So I'll give you a crazy example. You guys would know the CD shuttle in the car back in the day, right? So if you had and I know this distinctly because we built the BMW 3 Series axle assembly line, and I was shocked to learn that if you ordered the version with the CD shuttle, it got an extra shim inside the shock absorber.
Oh, wow.
So it goes down to the extra shim because you've ordered a shock absorber, so you can imagine the supply chain that's required to coordinate all of these things, right? And so the IT side of telling the production line what to do, and then the sub-suppliers what to do, has always been in our business. You've been able to custom order a car for 15 years now. So, and because we would typically make the component, we wouldn't make the whole car assembly line, we would make a component, and I alluded to an axle assembly. So we made, for example, the 3 Series axle assembly line. And so we would have to ingest a bill of materials, a subset of the bill of materials of the car for the axle, and that bill of materials would then have to drive the production line on what to build. And even down to different torque settings. So if you buy the 3 Series with the CD shuttle, I need to tell the tightening tool that's going to tighten on the shock absorber to tighten to 30 Newton meters, whereas the one without CD shuttle is 20 Newton meters, for example. And so we've had to build these dynamic production lines that adapt to every unique product through the production process. And so we've been forced into IT-OT convergence, and so that we didn't have an option. Before IT-OT was a buzzword, we were having to solve it somehow. And the interesting, the additional complexity that we were faced with in South Africa was most of the automotive manufacturers and tier ones, which is the majority of our customers, didn't have the big budgets to deploy SAP just systems in their factories. So because the volumes were low. And so they were just asking for help. Listen, guys, we need to sequence our production line somehow from a bill of materials, Jendamark, can you help? And in true fashion, not knowing anything about it, we said, yes, of course we can.
Our favorite word, yes.
And then I think this is in 2004, 2005, when we first started this just understanding. And we started to develop our first solutions, and what drove us to Beckhoff PLCs. So at that time, Siemens PLCs couldn't talk to IT systems without expensive licenses. Rockwell was a disaster. And the only soft PLC that we could buy that ran on a Windows PC was Beckhoff. And so we started to design the automation on Beckhoff, and that allowed us to talk to the PLC, the soft PLC back then, using a Windows application. And that was the emergence of IT-OT convergence. So we could have a Windows application that could read a database, the bill of materials existed in the database, that would then churn a bunch of data so that the PLC could understand it. And then when that product arrived in the station, the PLC would then say, what must I do? It'll get the data structures from the Windows application, and then the station would work based on the database structure, essentially. And that was in 2004. And that's how we got big German OEMs to buy Beckhoff, because they had, in South Africa at least, VW, Mercedes-Benz, BMW, and all the tier ones, was because they didn't have the big budgets to do the SAP solution that was available. And so they hacked a Jendamark solution into their production lines. And that was our journey into developing digital products. It was, again, not by grand design, but it was just out of necessity. I don't know if that's making sense.
No, it's perfect, because I can see your business in a way. And as you mentioned, how you were a supplier to the automotive industry, mechanical engineering, building, I suppose, production lines, and you heard your customers say, "We need help." You, like a good entrepreneur, a good business, said yes, and you've been meeting what they want, and also to a degree probably doing, because you have that insight, like you said, bottom up. You probably understand very well the nuances of the business, what's required. So. And you're building this technology, digital devices, IT-OT convergence, like an MES type of system, using these sort of technologies. Interesting quote on your website, Yanesh, because it sort of makes me think about, you mentioned here how you are designing tomorrow's production facility today. So what does tomorrow, you've done a lot. What does tomorrow's production facility look like?
Yeah, so I think I've got two phases in terms of our vision as a company, what we would like to achieve for our customers in terms of what does the production line look like tomorrow. The first, let me describe it in three different buckets. The one is, I think it's got to be much more human. We went through the typical definition, third industrial revolution, which is highly automated. And I think you need, and we've benefited as a business by automating a lot of things. And that is necessary to drive the cost of the product down. And that's clear. I think you've got to automate. If labor's high, you've got to automate. But I think there's always going to be a human involved in the story. And we've got some very automated production lines in Germany, in the US, that people are not able to manage because it's so complex. And so you have to have this balance between productivity and automation, because when it stops for days, as opposed to, okay, if it's much more simpler, more manual, you can get it going a lot quicker. So I think there's a balancing act to be placed there in terms of what does the future actually look like. I don't think it's completely automated. And I think that we should be using digital solutions to help augment operators on the shop floor, computer vision, AI, etc. And I'll send you some clips on some examples we've actually implemented at customers. So that's the one part of it. The second part of it is prescriptive AI. So this is use the shock absorber example again. So we obviously don't buy CD shuttles anymore. I don't know, we don't even buy CDs anymore, but I'm giving my age away. Nevertheless, let's say you do eventually order a BMW X3 with a CD shuttle option in it, and that requires a 13 Newton meter torque on the shock absorber for whatever reason. And let's say that and there's a 2-3% failure rate on achieving that torque, because none of them are 100%. If I could feed that back into the bill of materials and then the settings of the production line to say, okay, it is always when there's a 6-cylinder engine inside that vehicle that we have this 2% failure, for those engines, please slow down your tightening process to achieve a better output. So that's closing the loop. So I say it's like closed loop engineering, if you want, but it's using AI and prescriptive. So I think that's a key part of that 2-3% optimization that we're looking for. I think the massive steps we've achieved already, but there is opportunity for that 2-3% improvement in optimization by closing the loop. But that is really centered or critical to that is collecting the right contextual data so you can make the right prediction. Collecting uncontextual, stupid data, you just waste a bunch of time and money. So the sort of vision, first part of the vision is to be able to close the loop so that the optimization of the production line becomes autonomous. And obviously you have limits that you set within that so that if it gets out of the particulars, if it goes too slow, a human has to be involved to say, do you really want to set it so slow? Because maybe there's another contributing factor. So that would be the first phase. The second phase for me is really coming back to the human part. So I've got this vision where I think we have tried to make robots out of people in the factory by standard operating procedures, which is, I get it. So we want standard operating procedures to keep consistency, right? But I think technology now allows us, and I think we have all the pieces, we just haven't put it together to make our slogan in our digital business here is called Making the Fourth Industrial Revolution More Human. So take a scenario, think of your favorite production line that you might know of, right? And let's call it John. So I'm imagining this 3 Series axle assembly line, and let's call it John. And we all have one of these things, right? And we all now are starting to talk to our phones more than just type to it, right? So I want to be able to say, hey, John, how's it going? And through large language models and natural language processing and this contextual data that I've collected off the production line, knowing the context of who I am, to say, hey, Yanesh, assume I'm the plant here, right? Hey, Yanesh, it's going good. We were struggling at 10 o'clock today. There was a breakdown, but Phil, the maintenance guy, he got involved and we seem to be up and running again. I do see low stock on shock absorbers for tomorrow's build, but I've let Ed know and I think he's running with it. And we have that data today to be able to do that. And so I think there's a huge opportunity to allow less stress for plant heads and leadership in factories so that they have more space to think about tomorrow, to what we spoke about earlier, right? And I think that's using technology to make it more human. And even to the point where if you just ask any plant manager what they worry about is the unknown, right? So they'll like be laying in bed and they'll be thinking, is production running? Is production running? Has Phil organized the maintenance crew? Has Ed made sure all the things are in place for logistics, for example? That's what they think about. It's because they don't actually know. So if we can get it to a point where they trust the systems, the models, the predictions, and all that kind of stuff in such a way that they will be told if there is a problem, they then worry less. But the problem is they don't trust the systems today. They don't trust the people. They don't trust the systems. And so they continuously worry. So it's a terrible life running a plant. If you're a production manager, a plant head, it's a terrible life. You get used to it and it becomes normal, but I don't think that's human. So we've industrialized humans as opposed to make industry more human. And so for me, the final grand vision is to be able to allow a plant manager to think more about tomorrow than worry about if it's going to break or am I still going at the moment. And I think we've got all the pieces of technology. You can piece them together yourself right now, but it's about connecting them and making them so that we can make production more human. I hope I'm not rambling on and I'm making sense.
No, it makes a lot of sense to us. It's that connectivity. It's making not a on-off scenario. Where's the context? Where's the normalization in this data? So like you said, I can trust it. It makes sense. I had this line I shouldn't say line, but a comment I used to make to plant managers. If your factory could talk, what question would you ask it? I mean, what do you want to know? Because the data's there, it's just getting it in the right shape and form. And if you take advantage, like you mentioned, of AI, can it now tell me about tomorrow? Or I can worry about tomorrow.
See, Ed, you're a future visionary there with, this industrial co-pilots that are starting to come in, right? Like they've got the data sets to be able to iterate through large language models, enable us to talk to our data and give real-time insights into it. So you can ask these questions of your plant floor and get the human kind of style response out of your plant floor as well.
The future, though, is that you want the AI to ask the AI the question. So if you're stressed about something, you're going to ask the question. And I think that's step one to the process, to the vision that we have, right? So using large language, I don't know if you use ChatGPT 4.0, whatever you want to call it, to analyze a data set. It is crazy. You've got to try it. Take a huge Excel sheet, dump it into ChatGPT and ask it questions. It is mind-blowing what comes out of it. But and I think, like I said, we've got that technology, but I think it needs to be the next layer. If you want to make it more human, you want it to let you know that you should go look at that. You don't want to go and ask it a bunch of questions. So it's in phases. And so the vision, I don't know how long it's going to take. It's not tomorrow for sure. But to get the AI to ask the AI the right question so that if it is important, I need to let Ed know. So that Ed trusts the system to go and relax and be human until his co-pilot lets him know.
And then that means I have to be at that position where I need to make the call. The AI is talking to the AI and it needs me or a skilled person to make the right call. So what the AI should do now. It's interesting not we're part of it. Like you mentioned, like people think about the future, about robots taking over or whatever it might look like. But you're saying, no, that's not the case. We want to humanize the digitization so that it has more semantics with us.
So that we can become more human again. Because I don't think running a factory is nice. We do it on necessity, and I think look, there is some enjoyment. A lot of people do get some level of enjoyment, but that pressure, continuous pressure for 20 years of your life I don't think that's human. I don't know what you guys think, but that's not human. But if you can change that around using technology, you're enhancing human life, not making it more stressful. And I think we've been through the third industrial revolution where we've just broken ourselves. I come from the era where my dad worked in a factory 6 days a week. I saw him from 7 o'clock in the evening till 9 when I went to sleep. And then when I got up in the morning, he was gone. And that was normal. That was like, we didn't complain. That was just how life was, right? Because that's what he needed to do to run a factory. And I think that's maybe technology allows us to be a little bit more human, I think.
I mean, that's why we try and identify automation, right? To replace all the dirty, repetitive tasks that, add very little value, right, to the human existence as well. Like if you're trying to grind people out, then maybe that's the way to go. But we're trying to, I guess, identify this low-hanging fruit within operations to smooth line them, to make them more efficient, to actually, give the humans back the enablement portion to make these decisions without having so much pressure and time and criticality, to be more proactive in the decision making that we're able to make rather than reacting and having these high stress type environments. So it's really an exciting kind of portion where we're starting to adopt these technologies as well, and taking away some of those fundamental challenges that we face just through pure digitalization type projects as well. I guess one area that we're moving away from is this paperless societies, right? Trying to digitize everything as well.
Sorry, I just wanted to add one point to what you're saying is I also think that the human on the shop floor is not going away either. So, and I think that because my first job was at VW, actually. It was my dream job to go and work in a big car factory. And I think I learned a lot while I was there. And the 6 weeks, there was a 6-week period where I learned the most. And what they made us do as graduate interns after I qualified was to go and work on the factory floor for 6 weeks. And I was the poor guy that got picked to work night shift for 6 weeks, putting exhausts into a Golf 5, right, for 6 weeks. And I said to myself, that's a horrible job. It is really a horrible job. And I think that I really found a new respect for operators, and I guess it's kind of ingrained in me to try and make their lives easier, but not take their jobs away. And I think there's a difference between making their lives easier and taking their jobs away. And I think that, for example, if you an operator assembling something, could be a medical device as an example, there is a level of stress that they have to make sure that they're right, because they know if they have 3 failures, they get fired, right? I mean, that's just how the world is. And everyone will tell him or her that, look, there's a standard operating procedure in front of you. How the hell could you not do it? But they're building 1,000 of those things a day. It's human nature to make that mistake. But if we could introduce things that guide them, the Google Maps for the operator to say, listen, oh, by the way, you've made the wrong turn. Here's the U-turn. And if we have technologies like computer vision, some level of collaboration in a particular machine, that takes that level of stress away from the operator, that the systems are helping them as opposed to trying to catch them out. I think it changes the way you adopt technology, even for operators, not just plant managers. So I think for me, that's important. We're not going to get away from humans in unfortunately, some of those dirty environments. It's going to happen, but could we make it less impactful, less stressful, that the systems are helping them, like Google Maps, right?
That's good, Yanesh. That's good.
Yeah, absolutely. I think those technologies exist, right? We've got exoskeletons being put out so that exactly. no heavy lifting, right? In that sort of environment. And then we've got, those Google Map overlays of light across parts, right? You've got to put plug A here, you've got to put screw B here, and then you go through the step-by-step guide process to try and alleviate some of that, I guess, nuances that happen that sometimes are good and sometimes are bad, right? So we're just trying to create that consistency.
Yeah, and humans are not designed to do repeat things for 8 hours.
And that's the thing, is like, at least with technology, you can understand what the variances are. Should they be doing this particular repetitive task for 2 hours straight? Probably not in that sense. Okay, what is the break times? Do you get a higher performance out of the operator if they only do it for an hour and a half, right? Those types of things. And you mentioned computer vision, right? So the modeling, the overlay of the images, understanding stresses, like how are they lifting particular parts. We're starting to see that adoption of that technology to give us a real-time understanding of performance, risk analysis, those types of things. So it's really quite cool how we're progressing in a very short period of time.
I hope that we can all adopt the motto of making the fourth industrial revolution more human.
Absolutely, yeah. It's you're right, because we get fearful of industry gets afraid. Every time we've talked, I've gone to businesses and we talk about automation because they see us come in. And the operators get scared. These are the automation people. They we're going to lose our job. What's going on? They get worried because they need pay packets. We all need pay packets. We have to lift the standard of living for everybody, not just for the few. And automation and industrial revolution has done that. Every industrial revolution has made life better. And the fourth one shouldn't be any different.
The tractor.
Yeah, that's right. The tractor. PC, I mean, PLCs and all those relays and danger that we went through, those massive voltage boards and so forth. Now we're going for automation. Now this one should be the same. Should improve life.
The people that were worried about losing the job kind of topic, I always say, well, you can go back and pull the plow if you want.
Yeah, good one.
because that's what it was. We used to pull the plow. That's what it was. The plow with the cow or whatever it was. And now we've got a tractor, and it's been 70, 80 years since then. Do you want to go back?
Yeah.
So most people say, no chance. I don't want to go back to that.
I guess on that point, what kind of conversations are you having with operators when you start identifying those challenges? Like, how are you moving them into the right mindset to be able to start accepting these kind of technological jumps for them, because maybe they haven't done that in the past?
So I think it's a great question, and I think maybe I will add in a little sort of nuance to it, where I think that maybe we see things a bit different because of the environments we come from. So I actually had this conversation with Walker where I told him that actually 70% of the world's population comes from developing countries where we have massive unemployment problems. Whereas 20 to 30% of the technology and the thinking on Industry 4.0, in fact, 100% of it comes from environments where there's shortage of labor. So when Australia, I'll put Australia in that bucket, and I don't know too much about it, but I'm assuming that you're more first world, right? Your instinct or your first step would be, okay, I need to reduce the cost of my product, so I need to automate more because my labor costs too much. But 80% of the world doesn't live in that basket. We're the opposite. So when we approach a lot of our customers, and it's different to our overseas customers with our customers in India and in South Africa, where we actually try to digitize steps. So I'll give you a very simple example of maintenance. So maintenance is still very paper-based around the world, but very much so in India and South Africa. So we have a lot of customers where we say, okay, let's go and digitize a lot of your maintenance steps. So putting work instructions into a mobile app with videos so you can take experienced people that know how to do preventative maintenance tasks, putting that into an app so that young people, less skilled, less experienced, can actually do those tasks. That's digitization. That's actually not taking anyone's job away. That's actually enabling young, less educated, less experienced people to do more complex tasks. So that's really well adopted from an operator perspective, because they can then upskill themselves. An operator can now do maintenance on a machine, for example, because digital, and everyone knows how to use a smartphone, no matter where you are in the world, can now do those tasks. And similar in India, similar in South Africa. So I think that it depends on the kind of adoption that you're talking about. If we go in there and I've got a big robot under my arm, then there's the concern, right? I mean, that's kind of obvious that I'm there to take somebody's job away or reduce the number of people that need to be employed. And so there is that resistance, which is completely understandable. But I think that and it's difficult to explain to somebody on the ground, because they have a different perspective, and I respect that completely. However, in order for a plant to stay competitive, so if they employ 500 people, you have an option of them, not being competitive in employing 400 people, or at least employing 500 people and automating some steps, and potentially growing to 600 because they're automating more. So it's that balancing act that you have to kind of explain. And I think a lot of people don't want to understand it, and so it is difficult to convince the automation side of things. But I wanted to kind of separate automation with digitization. I do have an interesting story about digitization and resistance there. And that was surprising to me. I actually made a post about it. Was the biggest resistance we've seen to digitization. So take, for example, I gave you the example of maintenance tasks. So in this app that we created for our customers is a logging of downtime. So the operator can hit the app, press a button, it collects downtime. They can drop down menus, select what they want through their phones, that kind of thing, right? Or through a screen. And then we can log how long the machine was tagged as down and how long the maintenance guy took to respond. We use WhatsApp in India and South Africa, so it sends a WhatsApp to the maintenance person assigned. So then we can record when they got the message, when they closed it out, what was the reason for failure, and what did they do to fix it. So we have all of this kind of data that we're now collecting. And now the CEO of the organization can see the information live as it's happening, right? We thought it's a no-brainer, it's going to sell. But what's happened now on more than one occasion is when you pitch the idea to the CEO, they love it, right? And what happens is they then say, okay, let's trial it, and they ask middle management to please give their opinion. And middle management hate it because there's complete visibility from operator to CEO now. So when the operator says this machine keeps breaking, the CEO can see that. And then he or she would come down on middle management.
Because it creates more questions.
Yeah. Well, it empowers the operator to say their opinion, right? And most CEOs will back the operator. They're always, they're typically on the side of the operator because they know that operator is what adds value to the business. Everyone else is supporting.
Yeah.
I didn't anticipate the resistance from middle management. I thought we were making their life easier because we're getting rid of the admin role, which is true, but they get exposed. And so, do you want Big Brother looking at you continuously?
OEE and I guess that sort of visualization type portion just really exposes you to, if you're making bad product, how fast are you making bad product at the end of the day, right? As well. So
and the CEO can look at that on his phone or her phone. It's and it's that visibility across the organization is what makes them feel like it's Big Brother.
I know, and like from just businesses in general, right? Businesses love statistics. They love also KPIs as well, just in terms of general operations, right? Key performance indicators to actually manage their business. So yes, we get that visibility, but then what do you do with the data? Like, how can you, expect your management teams to react to bad KPIs or good KPIs, or what are the expectations around the data that you've now made visible to the whole operation? And that's something that you kind of have to have those open, hard discussions around, or make it achievable for the workforce to be able to actually impact those KPIs at the end of the day as well.
I think there's a big portion of middle management that's lazy. I'm sorry to say, but that's been a lot of my experience. I think there's some really good people in factories, but there's people that settle in, right? And it becomes an 8 to 5, whereas that environment requires a on-the-go person always driving improvement, always driving improvement, always driving improvement. It can't be a typical 8 to 5. And I think that visibility of data exposes that kind of person, and there are a lot of people like that in every country I've worked in, every society. There's that. You guys know it, right? There's a middle layer that's often just relaxed.
Well, yeah, it's that we talk about Industry 4 with Phil a lot, and we hear from a lot of our guests and people we talk to that Industry 4 is that people, process, technology, and people are very much part of it, and the processes are very important as this happens. And you're right that maybe they're left behind somewhere or other. How do you train middle management? How do you get them ready? Yes, they might be in the way, but what would be your advice then for the middle management or for the companies? What should they do with this group of people in that space?
Yeah. I think it requires the right leadership from on top. So you have to enable middle management to feel empowered. I think a lot of middle management feel like they're go-betweens, and they're always covering CYA, right? They're always trying to cover up a story so it looks good further up. But I think that you need to empower middle management from the top down to make decisions, to try things, to fail. I think most organizations don't allow middle management to fail. And so if you don't allow them to fail, they'll always try and stay conservative. And then they don't evolve and get innovative and try new things. And then the CEOs wonder, why am I stuck in the mud, kind of thing. So I think from a high level perspective, I think it's a leadership thing to encourage the failure, to encourage trying new things. And when it fails, learn from that and try again. And that's what I would, you see the middle management teams that perform the best are when the leader is a leader that allows people to, empowers them to do what they think is best, not telling them what to do, and when they fail, tell them why it's their fault. So I think it comes down to the leadership perspective, but I think a lot of plant leaders, not all obviously, are very much financially driven. They look at the profit and loss of the organization, and that's that. And it's changed a lot since I started my career to where we are now. There's a lot more CEOs that are just driven by the numbers. I'll give you an example that we all know about, unfortunate example of Boeing, where they, in my opinion, were the most innovative technology company in the world for many, many, many years. And they've lost that because I think they're looking at their market cap and their profitability only, which is important, obviously, else we wouldn't be around. But I think they innovation is also as important as your bottom line.
Yeah, I think some of the biggest companies in the world just really see innovation as their differentiator, right? They haven't sat on the status quo. They're always trying to find out, how can we do something better or differently to traditional systems? I guess that's why the birth of AI came, in the last decade or so, just because they were thinking outside of the box. If you look at how Google is exactly pushing the boundaries there. They're adopting all these different technology stacks. They're not necessarily acquiring them either. They're, doing that from internal use cases. If you look at Amazon, right, they're looking to drive their failure rates actually within their systems, because they know if they're failing, then they're innovating, right? And that's one of their key indicators of their progression is actually, we want to fail fast. We want to improve the systems. We want to drive innovation really. That's their key performers. So, and that differentiates themselves in the market.
You compare Tesla to some of the conventional OEMs, and you see the difference, right?
Recently, we heard from Ford saying they've been traditionally outsourcing all their components. Now they don't have any sort of understanding of what software works with what component, and Tesla rebuilt the model and created their own software, and they're more of a software company than they are an automotive company almost.
That concept of outsourcing is completely driven by the bottom line. How do I outsource all of my costs? And obviously with that goes a lot of my innovation. So my bottom line looks better.
It's talking about innovation, Yanesh. Jendamark, obviously, in the last 10, 15 years, you've gone through innovation, developed innovative solutions. What do you think have been the key innovation solutions that Jendamark have built with you and your team? What's some of the real game-changing innovations you've done?
It's hard for me to answer that, to be honest. I'd love our customers to say that. But again, with all of my answers, let me preface that with not necessarily making money out of it.
No, it's fine. Yeah.
Yeah, because some of the coolest things that we've made necessarily resulted in money, right? I kind of spoke about the bake-off days where we were able to write the Windows application that could talk to PLCs and smooth out that IT-OT integration. And a couple of years ago, when we were now kind of in strong arm using Siemens and Rockwell in the production line as we got bigger and started exporting, we didn't have options to use bake-off. We then wrote some backdoor software, if you want, which is no longer backdoor, it's now allowed, but back in the day was we were now able to change function blocks in the PLC without buying the Siemens licenses, which allowed us to then, create that IT-OT integration using Snap 7. I don't know if you know Snap 7 from Siemens, which back in the day was unheard of and you were not supposed to do it, but we used it, and we had production lines running using that backdoor communication, which was allowed our customers to be much more flexible, dynamically change their production processes. And so I think one of the game-changing things that we've offered our customers is, because I have all of the settings of my production line sitting in a database, I can then create an application that allows a no-code environment to change those settings, because changing settings in a database is pretty easy. And if I can change the settings in the database and that changes the way PLCs function, I then have an environment that is no-code. Process engineers can now change sequences, processes on the shop floor without being PLC programmers. So many of the production lines we deliver to our customers are programmed by process engineers as they input the processes into the production line. So that's one of the key, and I think is the future. So we kind of democratize PLC programming and outsource that to process engineers, who it should be. It's their job to define the process. And because they can't program, they have to translate that to PLC programmers' minds, and then they program it. So we've kind of short-circuited that. I think that's one of the cool things.
So configuration as code, right? Pretty much.
No code,
which is pretty cool.
Yeah.
That's awesome.
I think there's a couple on the mechanical side which might be boring for your audience, but I think, and again, this is not by grand design, it's by kind of necessity. In order for us to sell machines into Germany, for example, which is unheard of typically, we had to be better. And it started with robust mechanical design. And we've got quite a few, let's say, for example, in the catalytic converter world, these catalytic converters that go into our cars, every car has one or two of them. The changeover times of these production lines around the world was anywhere between an hour and 2 hours for commercial vehicle lines. And so we thought, okay, if there's a way we could reduce changeover time, it makes productivity much higher for our customers. And our founder, Quentin, he came up with this crazy idea on how to do automatic tool change on our machines. And to my dismay, he actually sold the concept to a customer and said, okay, we're doing this. I'm like, I didn't talk to him for 2 weeks because I'm like, that's impossible. It's never going to work. And in true Quentin fashion, he forced it onto all of us. And eventually we came up with this machine that was designed for tool change from the beginning and took tool change what was typically an hour to a minute. I'll show you some videos around it so that you can
that's fast.
really believe me.
Yeah.
And so that allowed us to sell a better product to the customer for more money. And that's purely mechanical innovation. So I think there's been a couple of scenarios like that where we've been smart on the mechanical side. From a conceptual perspective, we have a lot of laser measuring machines that measure different components, gears, catalytic converters, it's housings of components, for example. And one of the big challenges in manufacturing is verification and calibration of measuring devices. So built into all of our machines is a self-verification method. So we would move a laser down to a known set of measurements, discs, if you want, self-verify. And if it's out of range, we would raise an alarm and then allow the customer to have a self-calibration. It will then self-calibrate. And then if it still doesn't work, then you need a human needs to come in and solve it. But one of the biggest causes of recalls in the automotive space is devices not calibrated adequately. So you think of a torque tool that's supposed to be typing to 10 meters, but after time it's full of dirt and dust, and they forgot to verify it. And there's a wheel or a nut falls off an axle, and BMW lose their mind, they recall the car, right? And so having self-verification, self-calibration built into machines manages a huge risk for our customers. So that's one of the innovations. There have been a couple, but again, it was out of somewhat necessity as opposed to some grand design. I really wish I could say we had this grand design and we came up with these great inventions, but it's not the case.
Yeah, I mean, that kind of identification of the problem, right? We started off there, and then you have to evolve from that, I guess, that challenge. I mean, VW is probably one of those companies that, in the last decade has had some highlighted challenges and had to have those recall mechanisms in place as well to kind of rectify some of those discrepancies in quality analysis, right? As well. So yeah, it's definitely something.
The scenario was somewhat malicious, and I think that's somewhat self-imposed. But I think every vehicle manufacturer has millions and millions of cars that are recalled. I mean, you don't know about it, but when you take a car in for a service, you do the normal oil filter change, but there's about 5 other things that happen as well. But it's about being able to track and trace and know that Phil's car needs this, and so that traceability kind of thing is really important. If you go and have a look at any new car, there's websites, especially in the US, they love all of the recall campaigns, but every car has some level of recall.
Yeah, and that's true of any manufacturer, right? Whether it's, food and bev, that's pharmaceuticals, that's automotive. What we're trying to do is streamline the process and actually collect the data so that should a recall event actually have to happen, we know where that product is at the end of the day so that we can then action it and we reduce the amount of risk out on there to our customers at the end of the day. So yeah, it's a pretty critical piece of the puzzle as well.
Which is why IT/OT, to your original question, is so important.
Exactly. So, we have to have an interconnected supply chain. We have to understand, what all those kind of connectivity portions are, right down to, the grain of salt that was used to, to season our salmon coming through our line, right? So yeah, it's really a critical process. I guess on one topic we generally ask our guests. So myself and Ed are always learning. We're always trying to learn something new. I guess, what are you focused on in your learning journey? What are you kind of looking at to learn in that next aspect of your career?
So I'm always learning as well, and I go through these phases. And so I always find myself learning in two different buckets. The one is really technical stuff, like one of the challenges we have at the moment is because we ingest so much data from these production lines. How do we optimize reporting so that we could, at the moment we have, for example, a dashboard for a customer that's predicting when or the future bottleneck stations on a production line. But when they click the button to access that dashboard, it takes forever. And so it almost becomes a frustration and not used because of the live analysis that's happening on that particular system. So myself and the team, we're trying to figure out how do you optimize for that, and because we have transactional databases that run the production line that are not optimized for reporting, but we now need to have reporting effective if all of the tech we've created is going to be useful. So that's like one thing that's occupying my mind. And at the same time, I think what I'm starting to realize is making money out of a digital business is hard. So we have our bread and butter business, Jendamark, that makes machines, and we've tried and tested that over many years, and we've learned to keep innovating in that business and keep growing and adapting, etc. But a digital business is different, and I've kind of I'd love to get your opinion on this, but I think the difference between our automation business and our digital business is that no customer is ever going to buy a production line if they don't want one. So when they're ready to buy a production line, they've sorted out the budget, they know more or less kind of what they want, they have a product, they now need to compare my proposal to somebody else's proposal, but they're ready to buy, pretty much. Whereas on the digital business, you start an engagement with the customer when they're not ready to buy. There's no budget, there is no understanding, there's no education. So it's a long journey to go down with a particular customer, and you have no idea whether you're going to benefit from that in the sale, right? So the other side of my mind is now trying to figure out, how do you actually streamline that? How do you make it effective, educate the customer more effectively, understand, are they even ready to buy? Because you can't have 100 sales guys out there and you're only making one sale a month, kind of thing, because then your business is just going to go in one direction. So this digital transformation on the shop floor is awesome on LinkedIn and makes a lot of sense on LinkedIn, but financially it's not as simple as what people find. At least that's our experience, and a few other sort of startups that have started in this space share the same thing. So it's a difficult scenario. Plus, manufacturing has been through a tough patch over the last couple of years. Supply chain shortages. Most plant leaders have been trying to survive. The automotive industry is completely being disrupted with this EV topic. So they have no idea what to do. And so you go to them and say, listen, I want to put Industry 4.0 on your line. And they're like, well, I hope I have a line next year. The last thing I need is to optimize my line, and so I honestly have been finding it challenging to actually make money out of the digital business. Solutions, the product is there. It adds value. We know that. We've got customer feedback saying they love it, but we're not able to scale it to a point where it's actually generating a break even, to be honest. So those are the two things kind of occupying me at the moment, which is why there's a drive from my side on LinkedIn, etc. We're going to try to revamp the YouTube channel to make it much more educational as opposed to bragging about how good we are, which is things that I'm learning. I'm realizing marketing is much more complex than I've ever thought. I've got much more respect now for marketers than I ever had.
Yeah, I mean it's it's quite a funny topic because we've been on that sort of same journey, right? Is this realization that we need to educate the customer, we need to get them to understand some of the terminology we're using and some of the strategies that are out there, and really just kind of preempt any sort of need way before they're even realizing that they actually need it as well. So yeah, I totally understand those challenges as you start developing, a strategy around marketing, and you start, thinking about, okay, what does our ideal customer look like? Amazon does this really well, where they preempt you years before you even need it. We're seeing like AI and algorithms, giving you ads based on your mood, around your, what topics are you having around the breakfast table. You might be talking in the morning about, trampolines, and there one pops up in the afternoon for your local trampoline shop, right? So we're starting to kind of understand that we need to be really kind of tailored in that marketing approach as well. So yeah, it's been really exciting. Look, I just want to say thank you for coming on the podcast. It has been really a pleasure having you on the show today, and your insights into, I guess, automotive and the IT OT convergence has been really fascinating as well.
Yeah, thanks, Yanesh. I'm really, really happy to hear about your innovations you've done in the business, the way you see automotive going. Yeah, it's a challenging road ahead, and how you looking at multiple facets of your business and how that's leading forward. And I think it's been very valuable. So thank you very much. I've learned a lot today. So thanks for your time.
Yeah, thank you guys, and you guys keep doing what you do. I think it's, as I said, I think it's really important for our mutual benefit to keep educating. So I really appreciate what you guys do as well. And I'll soon be inviting you onto my podcast so I can hear more about what you guys do.
We want to get you back again. You got much more to tell. So
yeah, absolutely. I think the conversation's got to be had, and we love having the conversation, right? And so to our audience, I just wanted to say, don't forget to subscribe to Unplugged, an IoT podcast, for more episodes with industry leaders and innovators, and let's just keep the conversation going. So let's stay connected.
Thank you.